to know a concept called as wavefront. Okay. Suppose there is a still water. What is it? It's a still water. In that still water, let's say I give you a stone and you're going to drop a stone into that still water. Then immediately I'm sure that you will observe something like this, where these circles keep traveling, and the technical name given to these circles is called as ripples. Right? The water ripples are formed, as a result of which you can see them traveling. Basically, what are they? They are actually waves only. So this is what you are able to observe in a medium called water. Now, sometimes what happens is when light is traveling from one point to another, we think that it travels in the form of rays, but what actually happens is light actually travels in the form of something called as wavefront. Let me explain what that wavefront is. So wavefront, the technical definition is something like this. So write it down. It is a continuous locus of all points. It is a continuous locus of all points which are vibrating in the same phase. So let me tell what it is. So a continuous locus of all points which are vibrating in the same phase is what is called as a wavefront. That is a book definition. Okay. Let me explain what it means. Suppose I have a point source. Let's say I give you an LED bulb and that is the light source. From this light source, what will happen is you will have the electromagnetic waves that are coming out. Right? These electromagnetic waves will get liberated in all the directions like this. Because light is an electromagnetic wave of very high frequency and a smaller wavelength. Now let us look at what the definition has to tell us. So the definition says it is a continuous locus of all points which are vibrating in the same phase. What is the meaning of it? Means if I take a particular point. So let me explain what this phase is. If I take a wave like this, right? If I take a wave like this, phase is nothing but the angle. Okay. So at this particular angle, it has a particular value associated, like how you saw in the electromagnetic wave, how you saw it in the alternating currents chapter. We would have seen what is phase, right? Similarly, here also phase means angle. For that particular angle, we'll understand how much is the particle's displacement. Okay. So if I take all those displacements at the same time, so let me draw a better diagram. Let us say this is the source and 1, 2, 3, 4, 5, 6, 7, 8, something like this. So let us say this is the phase of a particle at this instant. The same phase is followed here, 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 here. So if I join all these points, then the shape that I'm going to get, what is it? Then the shape that I'm going to get is what is called as wavefront. Okay. So this is the meaning of the book definition. Let me make it simple for you guys. Suppose the meaning of this is, if I have a point source, away from that point source, what is going to happen is light will start traveling in such a way that it will travel in the form of wavefronts like this. It will travel in the form of spherical wavefronts like this, so that the energy is transmitted from one position to another. So basically, what is a wavefront? It is a locus. Locus means it's a moving. Locus is a shape obtained by all the moving points. Locus of all those points which are vibrating in the same phase. Now let me take another example. Let's say I have a linear source of light. Okay. If I have a linear source of light, then each point on the source will act like a point for the light to get liberated. Each point on this linear source is also a source only, light source. So this will release a wave like this. This will release a wave like this. It will release a wave like this. So it keeps on going. So when it keeps on going like this, I can find one particular point which is common to all. That is the phase at which those particles are oscillating. So if I take something like this, right? If I take something like this on the other side as well, then I get a shape like this. So the shape that you're going to get here is going to look like a cylinder. Means what I'm trying to say is, when you have a point source, if the light source is a point source in nature, then the light will start traveling in the form of wavefronts which are spherical in nature. Suppose you have a linear source of light, then at that point the light will start traveling in the form of a cylinder. Similarly, if you have set of parallel rays, means if the source is placed at infinity, then the wavefront will look something like this, which are plane wavefronts. So these are the different types of wavefronts that we are going to deal with. We will be mainly dealing with spherical and plane wavefronts in this chapter for many theoretical purposes.